Hi, I'm Julia Griffith in association with GEM-A. In this video, we will discuss the use of the refractometer, an extremely useful identification tool. We will talk about the correct use of the equipment and the possible results that you will see when testing various stones. This is one of the more complicated pieces of gemological equipment, but it's worthwhile pursuing accurate results as it can identify a huge majority of gemstones. A refractometer can be used to conclude the optical nature of a gem and to obtain its refractive indices. The refractive index, or RI, is a measurement indicating the degree of refraction that occurs within a gemstone. Let us first look at the equipment that we will be using. The refractometer consists of an eyepiece to look through, which also contains the polarizing filter, a glass stage for the gem to sit on, and a gap at the back of the equipment to allow a light source to enter the refractometer. For obtaining RIs, we will be using sodium light, which has a precise wavelength of 589 nanometers. Most modern refractometers have a sodium color filter positioned at the back of the refractometer so that any white light can be used. For older models of refractometers, a sodium light source must be used to obtain accurate results. When using a refractometer, we will also be using RI fluid or contact fluid. This is toxic and must be used with care. So please use in a well-ventilated room and be sure to screw the lid back on after every use to ensure it doesn't spill if it gets knocked over. And please always wash your hands after use. The RI fluid has a high RI, typically of 1.79 or 1.81, and this will limit what gems you can obtain results from. For gems with a high RI, which are any gems over the RI of your fluid, these will give you a negative result, which we will discuss in more detail later. Let us now set up our equipment. Let's start by positioning the light source behind your refractometer and turn the light source on. Turn off any surrounding light sources that may interfere with your observations. The stage should glow an orangey yellow, indicating that your light is in the proper place. Remove the polarizing eyepiece filter, as this is not necessary in the first stage of testing. Look into your eyepiece. Your eye should only be an inch or two away, and view the numerical figures down the right side. You can change the focus of the eyepiece by turning it clockwise or anti-clockwise to adjust it to a focus that suits your eyesight. Open the lid of the refractometer and place a small drop in the center of the table, and then ensure the lid is screwed back onto the RI fluid. The drop should only be 1 to 2 millimeters in diameter. Now look into your refractometer. You may be able to see a line or shadow edge created by the RI fluid, which reflects its RI. This is typically a very faint line that sits around 1.785 when using the 1.79 fluid. It's wise to note down the RI fluid value so as not to confuse it with any shadow edge readings from the gem later on when we're testing. Choose a gemstone to test. If you're a beginner, use known specimens to start with so that you know what results you should be looking for. Clean your stone and place it on the metal behind the glass stage. Then gently pull the gem towards you into the center of the glass stage without applying pressure so as not to scratch the glass. Look into the eyepiece and view any shadow edges which are created by the gem. You may need to adjust the position of your head to see the edges clearly. Position your hands either side of the refractometer and rest your elbows on the table to give you stability. Then twist the gem gently from side to side and view the shadow edges. We will be noting the number, movements and position of these shadow edges. We record RI readings to 3 decimal places. You may notice the internal scale indicates 2 decimal places only, so you must estimate as accurately as you can the 3rd decimal place. Let's now discuss the possible results. The optical nature of the gemstone is expressed by the number of shadow edges seen during testing and how these shadow edges move. One shadow edge indicates the gem is singly refractive. If you're unsure, confirm this optical nature with the use of a polariscope. For singly refractive gems, you can take its reading immediately from the internal scale and then use the constant sheet to identify your gem. Two shadow edges indicates the gemstone is doubly refractive. These shadow edges move apart and together again, so turning your gem on the refractometer is crucial to be able to see both of them. The higher value shadow edge is always fainter than the lower value and can be very difficult to see, especially if the two values are close together. If the gemstone is doubly refractive, its optical nature can be concluded as uniaxial if just one shadow edge moves, and biaxial if both shadow edges move. To record your results, turn the gemstone 360 degrees on the glass stage, and then position the gem where the shadow edges are furthest apart. Try to be as accurate as possible with this position and note the two readings down to 3 decimal places. We can now calculate the gemstone's birefringence, which is the value between the two refractive indices you've just noted down. This value is consistent for each particular type of doubly refractive gem and will aid identification. You can now calculate the birefringence by subtracting the lower figure from the higher figure that you have noted down. With all of this information you have obtained from the gem, you can now refer to the constant sheet to determine the identity of your gemstone. In biaxial stones, the shadow edges move independently from one another. To obtain accurate RI readings, each shadow edge must be observed and recorded at its maximum positions independently from one another. To do this, focus on one shadow edge at a time and rotate the gemstone in a full 360 degrees to determine its most extreme value. The birefringence can then be calculated from these two RI figures by subtracting the lower figure from the higher figure. And once your results have been obtained, compare these to a constant sheet to determine an identity for your stone. If you cannot obtain a full set of results, compare what you can, as this might be enough to identify the stone or at least narrow down its possibilities. When testing a gemstone that has an RI higher than your RI fluid, such as garnet or zircon, the RI cannot be obtained as the fluid RI is your limit. Any gem with an RI higher than your fluid will give a negative result, and in this situation the refractometer will appear dark or patchy light and dark, with one line showing approximately at 1.785, which is the RI of your fluid. Practice is key when using the refractometer, and please note that some gems are easier to test than others. So in the beginning, if one gemstone isn't working for you, move on to another until you increase your abilities. Some gems do show weaker shadow edges, some have scratched tables, so will give you fuzzy results, and remember that if you can't see any shadow edges, consider that you may have a gemstone with an RI over that of the fluid. I hope you found this video helpful. I'm Julia Griffith, thank you for watching and good luck with your gemology practice.